Okay, so for this video, I'm just going to look at what happens when we put f of x, which is again a sine bx plus c, and divide that function by the function g of x, which is a cosine bx plus c. So we have here h of x divided by g of x. So we'll have like a sine function divided by cosine. And I can already kind of tell what this I can already kind of predict what this is going to look like because, again, as we know from calculus, um, um, tangent is equal to sine over cosine. So I'm sure that if I put there it is. So if we look at the graph of this, and that is what a tangent graph looks like. It is an odd function, and the period is from negative pi to pi, or 0 to negative pi to pi, instead of negative 2 pi to positive 2 pi, like it was, like it is, like the period is for sine and cosine. So now we will just explore what happens when we change a first for h of x, which is a f of x over g of x. So nothing is happening except when a is 0. So that makes sense because 0 over 0 we're not going to have. That's not something that can happen, so that we aren't going to have a graph for that. That makes sense. But when we change the value of a, nothing's happening except at zeros, except when we have a equals 0. So this also makes sense because tangent, the graph of tangent doesn't really have an amplitude like the graphs of sine and cosine do. So this isn't varying the value for a, isn't doing anything. Let's see what happens when we vary the value for b. So yeah, so this definitely is giving us some type of change in the graph. And it's interesting because right now, when we have a positive number, a positive value for b, it is a positive function. It's increasing. But whenever we have a negative value, it is like a decreasing function. So, or each of the periods of it are decreasing because tangent itself is not all of tangent, but just in between these restrictions that we have, which is like negative pi to positive pi, the function is decreasing. And that also makes sense because we have pi, our period for tangent, the graph of tangent we know from calculus, is pi over b. So it looks like, it looks like when we increase the number for b, the asymptotes are definitely getting closer together, which just means that these the non-asymptotic pieces of the graph, or the space between them, it looks like is shrinking. And same thing when we go towards the lower negative numbers, except that it's decreasing this time. So that's interesting. I don't really have an explanation for that right now. Why? Well, I think it makes sense because this isn't symmetric. This isn't necessarily symmetric about the way that sine and cosine were. So it would have been impossible to like have them flip around like this is flipping around because this is tangent, and it does have it is symmetric about the origin and not the axis. So I think this makes sense now, why we have it the direction of it flipping when we go to negatives versus positives. So we get that. Now let's see what happens when we vary the value for C on this. So when we go towards negative numbers, it's moving towards the right, which is the positive side, and when we switch to positive numbers, it's the graph is moving, shifting horizontally to the left, which is the negative side, which I've explained in the previous two videos why that happens. I want to look into a deeper mathematical understanding of that, so I hope to add on to this like an explanation of why it is that when in the input when we have a x plus a value plus or minus a value y that shifts it horizontally. So that's it for this video.